Hey, algebra students, welcome to today's lesson on graphing inequalities. So let's just get started and review a couple of things. Just so you guys know, you are more than welcome to try this at home, like to review this lesson at home through Desmos later. But right now, we're just going to kind of go through these slides on paper. Okay, so you do not need your Chromebook out right now, but you're more than welcome to try this again at home with Desmos open. Okay, so let's talk about this first one where it says x is less than -2. When you create a graph for this, this is pretty much saying that they want any number that is smaller than -2. Okay, so on a number line, let's say -2 is here, right? The next biggest number, if you add 1, would give you -1. If you subtract 1, would give you -3. So on a number line, next to the -2 would be a -3 on the left and a -1 on the right. So for this, we use an open circle because this says that x can be any number less than -2, not equal to -2. So we can pick any number to the left. Okay, so this symbol means it's going to be open and you're going to shade to the left. All right, let's take a look at the next one. This says x is less than or equal to 0. So if this is 0, I add 1 to go to the right. I subtract 1 when I'm going left. This is going to be closed point because it has the or equal to. And we're also going to shade to the left because it's saying that x is any number less than or equal to 0. So if it looks like your left hand, you're going to shade left. So it's going to be closed at 0, shaded to the left. Okay, the next one, x is greater than 1. This is going to be open, and you're going to shade to the right because it's greater than 1. It wants all the numbers to the right of 1. Now, notice that in all of these inequalities, the x is written first. So you always want to try to have in your solution, the variable on the left. Okay, so here's a 1, 2, and then subtract 1 to see what number is to the left. Okay, so open point, and I want the numbers greater than 1. Those are on the right. Okay, last but not least, we have x is greater than or equal to -3. So if I add 1 to -3, I get -2. If I subtract 1 to -3, I get -4. Remember, when you go to the left, you're subtracting 1. When you go to the right, you're adding 1. This is going to be a closed point and shaded to the right. Again, if your variable is written first, then whatever the symbol looks like, the inequality symbol looks like. If it looks like your right hand, you're shading to the right. If it looks like your left hand, you're shading to the left, only when the variable is written first. Okay, so hopefully you guys were able to remember some of those rules from middle school. Okay, so again, later on, if you want to try this on Desmos along with your slides, you can. But in slide 3, they give you an inequality. 2x minus 8 is greater than 0. And they want 3 values of x that would make it true. So to solve inequalities, you pretty much solve them the way you do an equation. You cancel addition and subtraction first, then multiplication or division. Today, we're going to learn a rule about when you divide by a negative. That's going to be really important. Okay. All right. So according to this, x can be, if I read this out loud, x is greater than 4. So x can be any number greater than 4. Okay. So if I graph 4, I want the two, one or two numbers bigger, one or two numbers smaller. I can pick, now notice what they said, right? At least 3 values of x. So you can pick any 3 values, 3 numbers. They could be decimals, they could be fractions that are greater than 4. Okay, think of 3 answers, 3 values of x that are greater than 4, and write them down. They cannot equal 4 because it doesn't have the or equal to. Okay. For example, 6.7. That could have been an answer, right? That's a number bigger than 4. You could have picked 100. 100's bigger than 4, right? You could have even picked a fraction, like um, anything that would give you an answer bigger than 4, right? So you could pick decimals, you could pick fractions, you could have even just picked something as simple as 5. Okay, the next one is asking for one value of x that would make the inequality true, or if it has no solution, explain. There was a homework assignment that had a question like this, and some of you guys, I think it was the pink review sheet that we did previously. A couple of you guys thought this might be no solution, and a couple of you guys tried to divide. But remember, when there's variables on both sides, we tend to move one of them. Since we want inequalities to always have the variable on the left, variable on the left, I'm going to actually cancel the 3x. Okay, when there's variables on both sides, you have to cancel one of them. I'm strategically or purposefully canceling the one on the right to move it to the left. Okay, now, just because there's a 0 in your inequality doesn't mean that it's no solution, okay? No solution only happens if all the variables cancel. But if you notice, I still have 3x, so I have to keep going. Okay, less than or equal to 0. X is less than or equal to 0. So I want any number less than or equal to 0. So imagine on a number line, right? We want a closed point at 0 and we want to shade to the left. Okay, so just pick one number that is to the left or equal to 0. Pick that number and write it on your sheet. I'm going to go ahead and pick -2. You could pick any number to the left of 0. Okay, just like in equations, when you're checking if something is a solution, you can just substitute it. Okay, so when it says, how can you check that the inequality and graph represent the solutions, you can substitute. So I'm going to take my inequality, and instead of x, I'm going to substitute. Now notice, this says x is any number to the right of 2, any number greater than 2. So I can just pick any number that I want. Let's say I pick 3, right? I could pick 4, pretty much any number. Let's check the 3. If I substitute 3, and again, you can pick decimals as well. You could have picked 2.5, 3.75, any number to the right of 2. Okay, so 1/4 times 3 is 0.75, and that is bigger than 0.5. So since it gives me a true statement, then that means that it is a solution. X is greater than 2. Now notice that the 2 is open, so I could not have picked 2 as a solution. If I would have tried to substitute the 2, it would have given me a false statement. All right, so here's the big one, guys. The only difference between solving equations and inequalities is that if you multiply or divide both sides of an inequality by a negative number, you must flip the inequality symbol. Okay? So let's take a look at this example. This is the same as -1x plus 3 is less than 1. Okay? Just so you guys know. You see how the x is negative and the 3 is positive? So if I get rid of the 3 first, I'm going to be left with negative 1x is less than negative 2. If I divide both sides by a negative, okay, so you notice how the variable was negative, so I had to divide in order to get rid of the negative 1, I had to divide it with itself. So negative 1 divided by negative 1 is positive 1. I have to flip the inequality, okay? Flip this guy. So instead of it being a less than, it becomes a greater than. And then negative 2 divided by negative 1 is positive 2. Okay, so think about what this means. This means that any number to the right of 2 is a solution. If I forget to flip the inequality, okay? So if we would have written x is less than 2, okay? So if I had forgotten the flip, think about it. Less than 2 would be something like 1, right? That would mean that 1 is the solution. But when I substitute that into the original problem, 3 minus, right? Notice that I'm going to pick the 1 as my answer. I would get a false statement. 3 minus 1 is 2, and 2 is not less than 1. So if I had forgotten to flip the inequality, I'd be telling the wrong answers. The correct answer would be something like 3. So if I substitute 3 into the original problem, 3 minus 3 is 0, and 0 is less than 1, and that's true. So you have to flip the inequality if you multiply or divide both sides by a negative. Okay, so let's do a couple more examples. Notice that on this next problem, there are no like terms within the same side, but I do have variables on both sides. So I'm going to go ahead and cancel the one on the right to move it to the left, just so that my variables are always on the left. Then I'm going to cancel addition and subtraction. Then multiplication or division. Because I'm not dividing by a negative on both sides, right? Look at what I divided by. I divided by 4. I do not need to flip the inequality. Okay, go ahead and try the next problem. Take a couple minutes to do some of it on your own. Please pause the video right now and push play after a couple minutes so we can check our work. Remember, when you're distributing, you want to multiply the 2 times 1x and 2 times 3. Sometimes you guys forget to distribute to both terms. You have to distribute to both terms. Okay, notice that again, I am dividing both sides by positive 2, so there is no need to flip the inequality. You can also write your answer as 0.5, okay, for both of these. So this one wants all the answers less than a half. This one wants all the answers greater than or equal to a half. Okay, go ahead and try the next one. Pause the video. Let's try it for a couple minutes. So here I'm going to move the variables to the left side. That's going to give me negative 2x plus 5 is greater than or equal to 0. Subtract the 5. Divide by -2. So that means we're going to have to flip the inequality. Okay, because I'm going to divide both sides by a negative. So instead of being a greater than or equal to, it's going to be a less than or equal to. -5 divided by -2 reduces to 5 halves, or you could also write it as 2.5. So from now on, remember the rule. If you multiply or divide both sides by a negative, you have to flip the inequality. Okay, in the next example, they want you to create a graph of the solution. So after you finish solving it, you're going to create a graph of the answers. So this reminds me of the problem that we did on the other side, where you want to cancel the 15 first. That leaves you with -1x is less than -4. Because I'm going to divide both sides by -1, I'm going to have to flip the inequality. Okay, so flip the inequality anytime you multiply or divide by a negative. Okay, to create my graph, I'm going to go ahead and put 4 in the middle. Maybe two or three numbers that are bigger, 2 or 3 numbers that are smaller. Because they want the numbers greater than 4, but not equal to 4, we're going to use an open point and shade to the right. As long as your variable is written first, you know that whatever your hand that looks like, that's how you're going to shade. Okay, why don't you go ahead and give this last problem a try? So notice that the -5 is being multiplied with the x. How do you solve, and which of those answers matches? Think about how you're going to cancel the multiplication. Okay, multiplication is canceled with division. Since I'm dividing both sides by a -5, I have to flip the inequality. So the correct answer is A, shade to the left with a closed point at -3. All right, guys, as always, if you want extra help, feel free to ask for a pass to get help during lunch or ATR. You can even come in after school. Have a good day, guys. Bye.